This video will look at comparing two proportions using a hypothesis test. I'm using two proportions. I would be working with z-scores if I was doing this thing by hand, and I'm doing a test, so the name of it is a two-proportion z test. Starting with the TI-89, first note, I want to compare if I'm better hitting baseball with my right hand versus my left hand. Whenever I have multiple groups, it's a good idea to compare them. So first group is the right hand, second group is the left hand. I think I'm better with the right hand than I am with the left hand. So inside of my TI-89, I'm going into apps, and I'm choosing the option for stat list editor. I'm doing a test, so I'm going to choose the option for F6. So blue F6 gets me there. And I'm comparing two proportions, z-test, there we are. Number of successes for the first group, this was right hand, so I had 30 and 150. Left hand, I had 20 and 120. For the alternative hypothesis, I either am testing that I'm different, worse on the right, or better on the right. I'm choosing this last option. I think I'm better with the right. I could draw that picture out using my calculator if I wanted to verify what the normal curve looks like, but I like to just leave it as calculate. I'm going to get the numbers. This gives me a z-score of 0.70, and it gives me a p-value of 24.2% if I round a little bit. So when I'm doing this process using my calculator, I got a z-score of 0.70 or so, and I ended up getting a p-value of approximately 24.2%. That's a fairly large p-value, so if I was actually doing this test, I would probably fail to reject that null hypothesis, which means I don't have evidence that I'm better batting with my right hand versus my left hand. Let me show you how to do this now in your TI-84. So I'm going into my TI-84 Smart View here. I'm going into Stat. I'm going over to the option for Test. And I'm scrolling down until I see two proportion z-test. I have, number one is my right hand, so I have my right hand data, my left hand data, and I think that my first group is larger than my second group, so I'm choosing this option there. I can calculate or draw. I'm going to choose calculate. Just as a note, my calculator only knows how to deal with whole numbers, so if I'm given percentages, I have to convert those percentages into counts before I can do anything. This gives me a z-score of 0.70. Great, that's what I got before. A p-value of 0.242. When it says p, this means p-value. You may notice that it gives you some sort of p-hat. That p-hat is your pooled success rate. That's sort of like a weighted average of your two success rates. So I was successful 20% of the time with my right hand. I was successful about 16% of the time with my left hand, averaging 16 and 20. I'm roughly 18 to 19% successful overall. That's what that p-hat is telling me. It's if I ignore left and right and I just deal with one big group, that's my pooled success rate. And finally, if I want to do this thing inside of GeoGebra, I'm going to open GeoGebra. So I'm going to go to my desktop and open that here. When this pops up, there's going to be an option for probability on the side. I'm going to want to choose probability. I'm going into where it says statistics. And I am doing a test. Test is for test. Estimate is for interval. I'm doing a test. And I'm looking at the difference of two proportions. Null hypothesis, I can actually test how much of a difference I think there is between the groups. Typically, this number is just 0, meaning I'm claiming that there's no difference. If there is a difference, then I think that the first group is larger than the second. Number of successes for the first sample. Okay, well, I had 20 out of 120 for my first sample. Oops, nope, sorry. 30 out of 150. second sample, this was 20 out of 120. The nice thing about labeling your values early on is then you don't make mistakes like I almost did there, where I had the wrong values. I have my right-handed information and my left-handed information. This gives me a z-score of 0.70. This gives me a p-value of 24.18%. Again, that's a very large p-value. I would fail to reject a null hypothesis with any reasonable alpha level. I do not have evidence that I'm better at batting with my right hand versus my left hand. So that was how to do two proportions using a hypothesis test.